Hello, we are here for one more lesson of this T-Flex CAM training course. The topic for today will be the 3D milling. As we spoke in the previous lesson, the topic of this 3D milling will be split in some lessons. And the first one, we've seen the simple 3D milling on a surface, on an isolated face. Today we will start the different toolpath types in the boundaries 3D milling, where we will have a complete body with several elements and the milling or the tool types of milling that are possible to do with this solid body. So I've prepared two files to show you different perspectives of this 3D milling. And the first tool type we are going to see in this lesson is the roughing. So the preparation for this lesson was to make or to have this model and to create a new surrounding box that I've put in transparent mode so that we can see what is inside. This block in transparent mode tries to replicate a rough stock model that we have when we start to mill a part. I've done this in our example a little bigger that it should be normal, but the idea is to simulate a couple of possibilities, so that is why a little bigger size. The other model, it's also more or less standard body, and in this particular case replicates a cavity of a part, while this first one replicates something with this convex shape. So now to start to see the rough mode. As you know already, we need to go to the CNC menu, and inside of the CNC menu we have this icon called Boundary 3D Milling, where when we click it we have several types of toolpaths, and we are going to see this first one called the rough milling. So rough milling, the data we need to insert in the system. First, it is the actual part to mill, so I will choose this part in this list, and then I need to supply the rough stock model, so I will insert this element, and as you can see they are selected with different colors, so the part in green, the stock model in yellow. Now I will point to the toolpath file which I've created already with a couple of tools. I will make the first toolpath with the tool number 1, which it is a 60 mm diameter tool with 10 mm fillet radius, so a cylindrical tool. These parameters here, you know them already: feed rates, rapid and work feed rates. The allowance I will give, instead of 0, I will give 5 mil. Cooler, yes or no. Spindle, rotation direction and the number of spindles. For the example, is not very important. Then regarding the pass types, we have a couple of different types. So the standard one, zigzag, and with some variances, and with loops, spiral contours, changing direction of the spirals, and a couple of more options, but basically all with the same purpose, to make a roughing on the part. So I will use this spiral contour. Tool lifts, it is okay. We can work with step of passes, which I will use half of the tool, so 60 I will give 30 mil. We could use the crest height, not in this particular case, I will not choose it. Step of layers, I will say 5. And in all of these options below, I will leave only the circle interpolation and the precision with 0.1 in terms of value. So simply go and do it. Now, as you can see, the program has created a toolpath which we can do the simulation. Spiral mode, okay. And I will go to my list, change the properties, and I will change the color to light blue. Okay, that's it. And now I will create a second toolpath. We'll choose again the rough milling, again the same tool file, and now we'll choose the second tool, which in this case is a smaller tool. The first was a 60 mil diameter. This one is a 40 mil diameter and with a smaller radius of 6. Feed rates the same, I will not change. I will say allowance also 5. And in terms of the pass type, I will say also spiral contoured. Step of passes with the same purpose, I will say half of the tool, so 20 mil. And step of layers, I will leave it in 3. But the difference I would like to point now, it is instead of doing a rough machining, I will call it a semi-finished machining, but it's still roughing. And the idea of this machining, it is to create a roughing path, finding only the areas where we have excess material. And for that purpose, I will give the previous machining parameters. So diameter, the previous tool was a 60 mil, and the number of layers was, I think it was 8. So the parts are this one, and the block, it is this one. Let us confirm if all the parameters are okay. I think so. So it did not calculate correctly what we want. Let us open it again. So, okay, did not assume these parameters here. So give it again 60, number of layers, I think it was 8. And now it is correct. So it has found these areas, which I will turn visible, the first one, so that we can see. So these areas, the program found excess material considering the previous tool. And this is what I call a kind of a re-rough toolpath. So this is one of the options. We can do a couple of options more. Try to create a new toolpath again. So part and stock block. Tool file again. Choosing the tool number 2 once more. I will say in this particular case allowance, I would say for example 0.5. I will choose another tool type, in this particular case not spiral but zigzag. Step of passes, again half of the tool. These are directions, step of layers, they are okay. And we can turn on also this plunge machining, which mix the typical roughing tool type with this plunge machining to make a different, I would not say it is better or worse, but it's a different tool type and a different way to approach this roughing type. And we can do steps and define a value for the steps. We can define also the tool width roll, or in angle or doing in horizontal mode. So I will say calculate it, and as you can see, it creates a little different tool type, which I will change again to a lighter. So spiral contour, I think it's easier to see. I will change the number of layers. I will decrease a little the value, and okay, as you can see, it created a lot of points where the tool is plunging. So a little heavier type of toolpath. We can make a little variations out of this topic also. For example, only this tool type, I will take the plunge machining out, and instead I will calculate it first. So we are doing this kind of toolpath, and I will create, in this particular case, another option, the high-speed machining, which I can activate, and you'll see the difference. A little confusing, okay, a couple of steps only, but with a lot more movement. I'm not sure if we are able to see something on the machining simulation, at least something clear. Well, let us try to do something where the movement of the tool, it's done basically with a lot of circular movements, avoiding all the sharp corners and change of directions in corners. So it will create a much smoother toolpath, and in the end more fast toolpath in terms of the milling machine. Okay, so you see the difference, a lot of radius, but you need to be sure that your machine takes advantage of this kind of toolpath. Let us see on the second file, which is a little different, and this is, as I mentioned, a convex shape. So we certainly would need to give this stock block a little above the part to be milled. In this particular case, in most of the cases, there is no need to give it above. It depends on what you have to start, but it's a different case once everything that is to be milled is below the top level of the part. So let us try to create a roughing toolpath also, and I have two parts, one on top of the other. So you see the first one, it is selected as the shape, and the second one as this solid block. So if I choose again my tool file and tool number 2, which is a little smaller, I will say in this particular case also a spiral contoured part, step of passes half, and step of layers, I would say, let us say a small amount of layers so that we can see some of the movement. So this is a very basic pass, so spiral with a couple of sharp corners. Let us do a simulation on this. So you see that it has a lot of points. Okay, and the tool moves very slow. You know this parameter, we mentioned it already below, that we can make this a little lighter if we do this circle interpolation, and you can see this, it seems the same tool path, but on the simulation you'll see that much lighter. Okay, even that in this particular case it still has these sharp corners to change direction, so we can improve this a little more. So the idea now it is to connect this toolpath with a high-speed machining. So let's turn this high-speed machining on. Let's give minimal trochoidal radius on 3. We have a lot of parameters now for to define the steps of the trochoidal movements. Let us do the very basic and calculate. So you see that now the movement is much different of the simple spiral, and it has a lot of radius, which will help to have much smoother behavior in the machine. So let's try to simulate it also. So you see a lot of radius, and it will, in the end, it will save some load on the tool, and it will also improve the smoothness of the tool in the part, and it will lose less time in these direction changes that you have typically in this type of toolpath. We can make one final change so that you can see in terms of the high-speed machining what it is possible to do. For example, one thing that is very easy to see, if we give a bigger value for this minimal radius, so instead of 3, for example 5, you'll see all of these radius much smoother, okay, and bigger. So this is something that for sure, until what is allowable and possible by the geometry of the part, this is something that also will help to have a lighter program, and again a smoother part, and savings on the tool and also on the machine. So in terms of this first tool type for these bounded 3D milling possibilities, we've seen the majority of the parameters. We will continue these lessons with the other tool types, but for this first topic, I think these two examples are very easy to explain the different possibilities in these different two types of parts, the convex type and the concave type. So any questions or anything that you may need or may want to see better explained, contact us through the usual channels.